Hey guys, it's Nathan. In this video, we're going to be talking about map analysis. If you remember from a couple videos ago, we built a swarm bot, which builds a bunch of units, sends them to the center of the map, and charges the enemy headquarters after a certain amount of time. And while this strategy isn't bad, it turns out that it varies wildly in effectiveness depending on which map we play on. Let's take a look. So, let's play our old BattleBot against Example Funks player on 1 tower and on Rush. So, what ends up happening here is that our strategy tends to work a lot better when our soldiers have space to move around. In other words, on big, wide, open maps like 1 tower, where there's not too much in the way of defense and our soldiers have all the room in the world to move about and form a big, scary blob, our strategy does a lot better. So at round 600, I think, the soldiers will attack. So there they go. Their AI isn't the greatest in the world, but they do kill the tower, and they start marching toward the enemy headquarters. It's pretty clear that the soldiers from our swarm bot are going to win this one. But let's go to the next game. Oh, there's an exception. Instead of using Rush, let's use something like Lanes. This is also a very small map, and the towers are close together, so it will be a lot harder for our soldiers to break the enemy. Let's skip ahead a little bit. Now when our soldiers attack, they do hardly any damage. I think we end up winning on tiebreakers just because it's the example player, but our soldiers don't even manage to take out half a tower's hit points. This suggests that the map and the way that it's set up can play a very, very important role in deciding which strategy our bot should use. Anyway, a good next step is to think about the map and how we should analyze it. So, what should we do to analyze a map? Again, let's start with something simple. Let's say our headquarters is here, their headquarters is there, and there's some terrain in the middle. We don't want to get too complicated too fast, so let's focus on simple things for now. One indicator that can give you a good idea of how difficult it will be to attack the enemy is how much terrain there is in between you and your opponent. For instance, if there is a lot of void terrain, like this, let's pretend these blobs are filled in. Actually, I'll just fill them in. Something like this. So in this case, it will likely be very, very hard for your troops to move from your headquarters to their headquarters. Conversely, you have a very strong defender's advantage. Since it's hard for you to get to their base, it's equally hard for them to get to your base. However, if these terrain elements were gone and there's a wide open space around their base, then it's likely very easy for you to attack and damage them very severely. So, in general, the more terrain there is on a map, the more aggressive you should be allowed to be. Similarly, if you have a lot of towers in one location, like this, it's very hard to attack into that. And if your towers are very spread out, like on the map 1 tower, I think in the newer version of 1 tower, there's actually only 1 tower, but the version I'm using looks like this. It's very easy to attack into this because there's only one tower defending the base. So another feature of the map that we can use to shape our strategy is the locations of the towers. In general, if the towers are close to the headquarters and close to each other, then we want to be more defensive. Otherwise, we can be more aggressive. Anyway, the swarm bot that we currently have is quite aggressive. It attacks at turn 600 no matter what. And this can work in some cases, but in general, we want to be a little more careful about how we choose what strategy to do. I've created a new bot called Analyze Bot and copy-pasted the code from our old swarm bot into here. To get started, we're going to write a method to analyze the map that we're given. A simple first thing to do is we're going to look at the terrain tiles that make up the map. And we're going to check for each terrain tile if it's visible, and then whether it's normal or void. And based on the ratio of normal squares to void squares, that may help us decide which strategy to pick. For instance, on the map rift.xml, which I will show you right now, this is a good example of a map where there's a lot of terrain between your headquarters and their headquarters. In general, it's hard to attack because the terrain just restricts the movement of your army so much. Whereas on a map like onetower.xml, there's much less terrain. So this could be a useful first step in deciding which strategy to do somewhere down the road. So let's get started writing a method that computes the ratio of normal tiles to void tiles for some selection of tiles on the map. Obviously we can't check every tile, but we're going to try and check as many as we can. Let's get started with a method which we'll call analyze map. So first of all, once again, the headquarters will be doing all the heavy lifting here. So what we can do is we can create static variables inside the headquarters which persist from round to round. In other words, we can store information in the headquarters, and the headquarters can use these variables across rounds, but no other robots can use these variables. Let's start by doing this. We'll create variables xmin, xmax, ymin, and ymax. And we'll set them equal to Sorry, that was a bit of a mouthful of code. Anyway, what we're doing is we're setting xmin equal to the smaller of the x values of your headquarters and their headquarters, and xmax to the larger. Similarly for ymin and ymax. What this does is we have effectively created a rectangle bounded by the position of your headquarters and their headquarters. In other words, we've selected the rectangle with corners at your headquarters and their headquarters. And the plan is to analyze all the terrain inside that rectangle. This isn't perfect, but it should give some idea of how hard it is to get from your headquarters to their headquarters. Let's get started on actually analyzing this stuff. So one initial idea is to use two for loops. These should be less than or equals. So we can get the terrain tile using rc.senseTerrainTile, like that. And then we can check if it's a normal terrain tile. If it's not a normal or a void tile, it may be a tile of type unknown, which means we shouldn't really touch it. There is the problem that we need to explore the map before we can do too much analysis on it. But for now, let's just work on getting the analysis code down. Let's create variables which we'll call total open, or total normal, total void, and total processed. In this if statement, total normal plus plus, total processed plus plus, and then this if statement, total void plus plus, total processed plus plus. Finally, let's create a double which we'll call ratio, which will be the ratio of normal to void squares, and we'll create a variable which will tell us when we're finished analyzing, so we don't have to do it again. Once this for loop is done, we can set the ratio. Now we can hook this statement into analyze map, or rather we can just call analyze map inside the execute statement. First we'll check that it's not finished already. So at the end of all this, we'll have a ratio of the number of normal squares to the number of processed squares, where a processed square is an explored square on our map. This should give us some idea of how much void terrain there is between our base and their base. This actually has a bit of a problem though. The problem is that this can take a long time, and it may exceed the number of bytecodes that we have available in one turn. This isn't the end of the world, because it will throw an exception and then continue the computation the next round, but it's still very costly, so we'd like to avoid it if possible. We can actually rewrite the code slightly so that if we're running low on bytecodes, we'll stop the computation and resume it the next round. The way we do this is by using a while loop instead of a for loop. So we need to declare two more variables, which we'll call xpos and ypos, which represent the current map location that we're processing. We'll remove these two for loops. and we'll put a while loop in instead. So at the end of the while loop, we'll increase x pos, which represents the x position of the square we're processing. In this way, after we're finished processing a map location, we'll increase the x position by 1. And if the x position is too high, we'll reset it to the minimum value and increase the y position by 1. In this way, we process every square in the rectangle that we want to consider. Rather, we process every map location in the rectangle that we're considering. We know that we're done processing once the y position is greater than the max y position. If you're not quite seeing why this works, think about it for a while or ask us. It's a little tricky to get down. Finally, we need to make sure that we're not running low on bytecodes. The way we do this is by using the clock.getBytecodes left statement. So let's say if we have less than 100 bytecodes, we'll return. This way, if we're low on bytecodes, we won't throw an exception, we'll just return analyze map. And this is the last thing that is called by execute. So if we return early from this, the execute statement will finish, and we won't run over our bytecode limit. So this should help us, particularly for larger maps. It probably won't matter at all for any of the maps we've tested, but it's just something to keep in mind if you ever write your own method that could potentially take a long time. In the next video, we'll look at ways to make this analyze function better. In particular, we want to make sure that the number of squares that we're considering isn't too low. See you guys next time.